Energy demand fluctuates throughout the day, which impacts energy prices and costs your money. Utility must always have enough energy supply to accommodate customer energy demand. Now imagine a really hot day when everyone turns their AC on. At the same time, energy demand spikes, the grid gets stressed, and electricity prices go up when demand is high, supply is low. Utility must find a way to respond and restore the balance. The option 1 is utility can fire up plant that is extremely costly and emits an enormous amount of CO2. Option 2 is utility can use renewable energy sources such as solar wind, but they are not always available during high demand times. Option 3 is utility can buy electricity from another country. This is also costly and not possible right now in Sri Lanka. The option 4 is utility can directly work with their customers through demand response event. Sounds great, right? Our project focuses on feasibility of implementing demand response for large facilities in Sri Lanka. There are many types of demand response schemes are available across the globe. From the help of literature, we found best two DR schemes for Sri Lanka. One is interruptible or curtailable load scheme. Another one is demand bidding. To find the behavior of these demand response schemes, we have developed algorithms for both schemes. These algorithms are analyzed in a hypothetical miniature model contains 14 power plants and 13 industrial and general purpose facilities in different time periods and different level of curtailments. This is the flow chart of the algorithm we have developed for interruptible or curtailable load program. Until I exceed M, program runs. If agreed curtailment is equal to the demand reduction, total incentive is calculated. If not, penalty value is calculated. Incentive per unit energy is obtained from the algorithm. If I exceed M, program will be ended. This is the flow chart of the algorithm we have developed for demand bidding program. Program starts from the low demand bid. If the difference between demand curtailment and demand bid is in the mentioned range, corresponding bid price is selected and incentive will be calculated. If not, demand bid will be increased to next value. Until I exceeds M, program runs. Otherwise, program will be ended. In software implementation part, we have developed two desktop user interfaces. First user interface provides the load curve visualization of each demand response participants and utility. Here we import the load data from Excel file to MATLAB. If we select customer name, it visualizes the load profile of each customer. For an example, if we select Empire City, you can observe the load curve. If you select British Business University, you can observe the load curve also. And also, if you select the cable manufacturing company, you can observe the load curve. And finally, you can also get the load profile of the utility. This is the second desktop user interface we have developed. Here we have to give demand response scheme, time period and curtailment percentage as input. For an example, if interruptible curtailable load scheme is implemented at 9 am to 10 am period, for 5% curtailment, we can get the profit of each customer, total profit for the customer, incentive per unit energy and total utility profit. For 10% also, we can get the result. If demand bidding is implemented at 2 to 3 pm, for 5% curtailment, we can obtain all these data. And also for the 10%, we can get those data. When we analyze the result, IC program is much beneficial for the customers while DB program is much beneficial for the utility. To have a proper conclusion for the result, we have validated using two scenarios. In first scenario, we have divided electrical customers as commercial facility and industrial facility. In second scenario, we have divided electrical customers as day working facilities and 24-hour working facilities. In first scenario, we have got the result same as previous. In second scenario also, we have got the result same as previous. From these two scenarios, the result obtained can be validated by the conclusion that by implementing the algorithms in the selected two schemes, customer can get more benefit from IC program, while utility can get more benefit from DB program. DR concept is a new concept for Sri Lanka. Most of the people in the country haven't even heard about it. Therefore, the first step should be to attract a lot of customers to participate in DR program. From the result, it's obtained that the IC program gives more benefits to the customer than DB program. Hence, when implementing DR in Sri Lanka, it's recommended to first implement the IC program to attract customer. In the current state, utility is having more losses in power sector. To have profits for utility is also an objective of implementing DR in Sri Lanka. When enough customers are attracted to the DR program as a second stage, the program can be moved to implement the DB program to have more benefits to the utility. Therefore, it can be concluded that implementing DR in Sri Lanka can give solution to the existing problems in power sector while giving mutual benefits to the both utility and customer.